Hello, welcome to Lesson 11, Understanding Polynomials. Our learning target today is to classify, add, and subtract polynomials. So by the end of today, we will be able to classify a polynomial and then learn strategies to both add and subtract polynomials. To classify a polynomial, we have to know what the degree of the polynomial is, and then also how many terms are contained in the polynomial. Below are some new concepts, and we'll just hit some of the main points of each of these concepts. A monomial is a number, a variable, or the product of a number and a variable with whole number exponents. The prefix mono means one, so we're just talking about one term of the polynomial. A polynomial is a monomial or a sum of monomials. So each term in your polynomial will be separated by either a plus sign or a subtraction sign. Each term is going to have a degree. The degree of the monomial is the value of the exponent. So this one would have a degree of 4, and this monomial would have a degree of 3, so on and so forth. When you're talking about the whole polynomial, you're going to look at just for the greatest exponent of any term that's in the polynomial. So this polynomial example, the degree of the whole polynomial would be a 4th degree polynomial. We're going to practice putting polynomials in standard form. Standard form is when all like terms are combined, so any of the variable terms that have the same degree, we're going to combine those together. And then you're listing them in sequential order by exponent. So starting with the highest degree and then listing them the next lowest degree all the way till we get to the constant. A polynomial function is going to give you an output in terms of x. So polynomial functions can represent a wide array of situations like financial equations, profit, loss, things like that. So a polynomial function is going to usually be represented with p of x, and then the x is going to input into the function, and then you will find an output once you evaluate for that x in there. The leading coefficient of a polynomial is going to be the coefficient, or the number in front of the variable of the term with the highest degree. So in our polynomial we've been looking at, 3 is going to be that leading coefficient. And lastly, your constant term, that's the term that is not going to change in the polynomial. That is going to be the number without a variable. So these concepts are going to be what we use to put a polynomial in standard form and then start to classify the polynomial once we get all of our terms combined. So in example 1, we have a polynomial that's kind of in disarray. We've got our terms all kind of mixed up. We've got some y to the third terms and a y and some constants. We're going to put this in standard form, which from above means that we are going to start with the highest degree and then list each degree in sequential order all the way down till we get to possibly a constant. Once we do that, we'll get to identifying the leading coefficient and the constant term. So taking a glance at my polynomial, my highest degree is the third power. So I'm going to combine my third power terms to make one single y to the third power term. I scan my polynomial again. I look for any y squared terms. I don't have any of those. The next thing I do have, though, is a y term. So that'll be the second term as I'm writing my standard form. Lastly, I'll look for any constant terms. And I've got a constant term of 5 right here. And then I've also got a constant term of -5, which is going to combine to make 0. So my standard form of my polynomial will be 6y to the third power minus 2y. Lastly, we'll name the leading coefficient and the constant. So leading coefficient is the coefficient of my highest degree monomial, so that's going to be a 6. And my constant term is the one without a variable, which I don't have a number listed, but I could add that term, and that would make my constant 0. So if we don't have a constant, your constant in the polynomial is just going to be 0. Second part of the first learning target where we're classifying is starting to look at the math terms for these polynomials that relate to their number of terms and then classifying by degree. So in classifying, you need to know two things. You need to know what the degree of the polynomial is, and then how many terms, how many different terms it has. Because remember, we will combine any of the like terms to make one single term. If your polynomial does not have a variable, it's just a number, that means it has a degree of 0, which is a constant. If we have an x to the first power, that's a first degree, which we call linear. If we have an x squared second degree, that is going to be a quadratic. X to the third, our third degree, is cubic. X to the fourth, if our leading term is the fourth degree, that's quartic. And then x to the fifth is a quintic. So the first thing we look at is we look at the highest degree that we see in the polynomial, and then we are going to classify it by one of those 5, actually 6, types of degree. The second thing we look for is the number of terms. So I've already listed the number of terms. So the number of terms are the number of terms in the polynomial that are separated by these addition or subtraction signs. It's just the number of different terms that we see in the polynomial. The terms we're going to use to classify the polynomial by its number of terms is monomial, binomial, and trinomial. And these terms are used in other areas as well. So mono means 1, bi means 2, and then tri is going to mean 3. If we get beyond 3, we just name it by how many terms it has. So 4 term, 5 term, 6 term, so on. But those are the two ways that we are going to classify. So we are going to use these mathematical terms whenever we classify. We're not just going to classify using numbers. We'll actually use these vocab words. So let's try example 2. We have 2 to look at. First, we'll look to simplify, then we'll see how many terms they have, and then what the highest degree is. So looking at example A, I looked first to see if I could combine any like terms. I do not have any terms to combine. So now I'm ready to classify. I look at the highest degree, which is a 3, looking at the exponent. Then I count how many terms does the polynomial have. It has 3. So you can see if you have a degree of 3 and 3 terms, practice, take a second, think about what is this one going to classify as. If you thought cubic trinomial, you are right. So let's look at part B. Part B, we have to combine terms to get this simplified. So I scanned through and found that we have 2m to the fourth term, so we'll combine those 2 terms. And then we have 1 m term that will come along as part of the polynomial. Now I'm ready to classify. I look at the leading term and look at what's the degree, which is a 4, and then count. There's 2 total terms. So think about how you would classify this polynomial. If you said quartic binomial, you are correct. So that is our 2 examples. We can look at how we classify. Just make sure that you are simplifying, combining like terms wherever possible, and then the degree of the polynomial is only the highest degree. So you will have multiple exponents in there. Possibly you're only classifying by that highest one, and that's it. Second half of our learning target is we're going to start to talk about how we can add and subtract polynomials. There's a couple ways that you can do it. On the left here, you can start to organize your terms by their degree and then vertically add them up. Very similar to how you add up like the ones place, tens place, hundreds place when you started adding back in elementary school. So we'll first look at how we can add vertically. So I've got all my terms lined up. So we made a column for the cubics, the quadratics, the linears, and then the constants. So let's go ahead and add them up just like we did back in elementary school with our vertical addition. So when we add vertically, we're going to get 9, 0x, 4x squared, and 10x to the third. If you're doing it this way, you are using the commutative property to rearrange, and you are putting them in standard form. Just be careful, like for this subtract x right here, I got to make sure I count that x is negative in my problem as I add them up vertically. The second way we can do it is just to combine like terms. So here I've listed out all the terms. The associative property says we can add any 2 terms we want together first. So we'll get rid of those parentheses and we can start to combine these like terms. So we'll do that next. So I've started by identifying all my like terms. I've got a x cubed, I've got x squareds that I can combine together, I've got linear terms I can combine together, then I've also got constants I can combine together. So we get our terms combined together, we get the same thing, 10x to the third plus 4x squared plus 0x plus 9. The linear term 0x, since it's a 0, we do not need to write that in. So we're left with 10x to the third plus 4x squared plus 9, which is going to be a cubic trinomial. Let's move on to subtraction. So if we get things lined up vertically, we can go ahead just like above and we can start to do our subtraction. Just keep in mind, we are doing subtraction, so some of these integer rules apply. Like when I minus a negative, I'm actually adding. So just be careful on that, and let's find our results. So when we subtract each term, we should be left with negative m to the third plus 4m squared minus m minus 3. Now we'll look at the alternate strategy where we can combine like terms like we did above over here to solve this subtraction. Each term after the subtraction sign is going to be taken away from the first polynomial. So we can think of that as like being a -1 distributed. So each of those terms that I have drawn out this arc to is going to change to its opposite. And then all we have to do then is just add our terms like we did in the previous problem. So just a quick note, when I changed each of those terms to its opposite, I got a negative m to the third, I got a positive 2m, and then I got a negative 5. Now we're ready just to add those terms together like we did on the previous problem. So I've taken a look at the polynomial and found that the m's can combine together and then the constants can combine together. After combining the like terms, we'll have a negative m to the third plus 4m squared minus m minus 3, and that would give us a cubic 4 term. So either way we slice it, we're going to get our polynomial to be the same. So there's two strategies there. You can kind of decide what strategy you like the best, but both are work equally well. To finish up, a company's profits are listed in the polynomial below, and we want to write a polynomial expression that represents the difference in profits. So difference does mean subtract. I am going to use the vertical subtract method. You can try either method you'd like, but that's how we will solve this one. So we can organize vertically. We've got our quadratic, we've got our linear, and then we've got our constant. Now we're ready to subtract. So in our first subtraction, we've got a negative 0.003, which I'm just kind of thinking of as like -3. And then I'm subtracting a -2, which really means I'm going to be adding. So -3 minus a -2 is going to give me -1. So -3 plus 2 brings me up towards -1. So I'm going to have a -0.001x squared. Next subtraction, I'm doing 25 minus 21, which is a positive 4x. And lastly, we're doing that subtract to negative again, so we got a -15. Don't worry about the zeros, just think -15 minus -17 is like -15 plus 17, which brings me out of the negatives to plus 200. So there's our difference in profits. We've got a negative 1/1000th x squared plus 4x plus 200. So to recap, in this lesson, we looked at how we can classify. So you want to make sure that you combine like terms where possible and then find where that leading term is with the highest degree. And then we've got strategies for both adding and subtracting polynomials. So you're now ready to look at your practice assignment for lesson 11. Good luck, and we'll see you next time.